Welcome to log blog number 10. Today we're going to analyze the situation defined by this equation. It's exponential, as I mentioned at the end of the last video, but we will have to use logarithms to answer these questions. But first, today's anagram: Apple, Macintosh, as in the computer. Rearrange the letters to make a phrase that makes sense. So, this could represent the temperature in degrees C of a cup of boiled water. T is in minutes. So let's answer the questions. What's the temperature at the beginning? The temperature at the end, if you wait a long time. The temperature at 10 minutes, and then the time it takes for the temperature to cool down to 40 degrees. Well, if I plug 0 into here, anything to the 0 is 1. 80 times 1 plus 20 is 100. So the original temperature is 100 degrees centigrade, in keeping with a cup of boiled water. If you wait long enough, then 0.8 to the infinity becomes what value? Yes, 0, because 0.8 squared is 0.64, which is smaller than 0.8. Every time you raise it to another integer or any number, it's going to become even smaller. So this becomes 0. 80 times 0 plus 20 is 20 degrees. So that's room temperature, which is what you expect the cup of boiling water to cool down to eventually. Okay, what about 10 minutes? Well, now we have to do some calculations. So if I plug in 10, it's kind of hard to predict that, because 0.8 to the 10, who knows what that is? But I've done the calculation, and it's about 28.6 degrees centigrade. Now let's find out the time it's going to be or take to cool down to 40 degrees. Well, this is already past 40, so it's going to be less than 10 minutes to get to 40 degrees. So let's calculate that. Here I put 40 on the left-hand side. And then the question becomes, how do you solve an equation like that? Well, the first thing you should do is bring the 20 over. So 40 minus 20 is also 20. Then divide it by 80. If you take the log of both sides, when you have 20 equals that's a product. So you have to use the formula for the log of a product, which we've talked about in the last couple videos. But that gets messy, so it's better to divide by 80. So 40 minus 20 is 20. 20 divided by 80 is a quarter. So I get 0.25 equals 0.8 to the t. Don't need the brackets anymore. Take the log of both sides. I'll do all the gory details just in case you're not too familiar with the steps. That's going to be the log of 0.8 to the t. And then we know that the log of a power is the exponent times the log of the base, or the log of that number. I should say, and I'm using base 10, of course. So the t comes to the front. So the t will equal log of 0.25 divided by the log of 0.8. And calculate that, which I've done, you get 6.2 minutes. As predicted, it's less than 10 minutes. Now let's graph all of this information to see what the temperature of the cup of water that was boiled looks like. So I guess I don't need most of this stuff here. Can I remember this? I think so. Okay. So I'll graph it over here. This is time in minutes. This is temperature in degrees centigrade. That was 100. That's 20, let's say. 10 minutes. Let's put it here. So the original temperature was 100. The temperature eventually is 20, so that the curve will decrease and approach this asymptote. At 10 minutes it was 28.6 degrees. So if that's 20, this might not be super accurate, but I guess it's not. It'll be about here. And it takes 6.2 minutes to get down to 40. So let's say that's about here. Close enough. So the graph looks like this, to the best of my ability. And there you have it, a quick and dirty sketch of this relationship here. Okay, in order to finish off here, let's look at today's anagram. Any ideas? How about laptop machines? Not that they're all laptops, but it is an anagram for Apple Macintosh. That's a cute one. All right, see you next time. The series is almost over. Take care.